Hello, good afternoon. So, as it's left to me to introduce myself, so I quickly whipped up a slides there. Well, not really, but essentially I'd like to think of myself as an old git, mainly because I remember Java 1.0. My sort of journey into security was through a long time of developing software. I made software for a lot of companies, a lot of banks, a lot of payment systems, a lot of front ends, middleware, and it gets boring. I'm sure there's a good metaphor to be had in banking, but I never forget the story that a friend of mine told me about a router that was hung in mid-air and secured literally by gaffer tape. Now, we might think that this sort of literal gaffer tape is something that doesn't happen all that often, but trust me, it does. And the more critical the infrastructure, the more gaffer tape is used. Simpler times. So more recently, I've moved into the AppSec area, and at the moment, I work for the UK's leading tax collection authority, helping them to secure over 1,000 microservices. And that becomes important because when we talk about it at scale. So, in this talk, I'd like to talk about denial of service, but not the kind of denial of service attacks where you just get lots of clients and lots of packets and things stop working. So I'm not talking about the low orbit ion cannon to overwhelm the system with brute force and ignorance, but more about sort of targeted strikes, more cruise missiles than carpet bombing. I'll also be using the play framework as an example where there's a specific vulnerability. And I'll talk about how modern infrastructure can actually amplify this type of attack. And I'll have a few more interesting denial of service vectors. So, on the previous slide, I mentioned the low orbit ion cannon, so often used in distributed denial of service attacks. But like I said, this talk isn't about that. So I'd like to stick with Star Wars. Here I'm sort of likening the distributed denial of service attacks to the Imperial fleet of heavy lumbering Star Destroyers that will fire lots of shots annihilating everything in front of them, but not necessarily hitting anything. And the sort of precision attack is like your neighborhood-friendly gang of rebels with their X-Wings. Taking out a Death Star in a single shot. So, and this is my last bit of Star Wars metaphor, I promise. When you look at the architecture of modern systems, a lot of the time there's a content delivery network at the front, then there's like a web application firewall and countless load balancers and proxies before a HTTP request actually hits an application, the kind of thing that the developer writes. So the attack has to navigate this particular trench and get to that exhaust port unharmed before it can do any damage. In my opinion, that's why distributed denial of services attacks are often limited, because all these systems in front of it, they're there to prevent bad things to get through. So, let's look at a specific example of how a relatively simple payload can arrive at its targets and do some serious damage. So I've picked out this particular CVE because I found it, and it's in the play framework, and it's triggered by passing a payload like this through. It's essentially valid JSON. It's a single element that has an array, which contains an array, which contains an array, and then you do that 30,000 times, and you put a 0 in it, and you close them all. So it's valid JSON, but it's the parsing of it actually caused the play framework some problems. Specifically, it ran out of memory. And then because it ran out of memory, it basically fell over. It sort of crashed and died in a heap and returned a turn of 503. So that's kind of neat. The interesting thing about that was that it happened in where the passing of the payload happened before it even did any authentication. Passed the payload, it fell over. Not really much that you can do to secure it, except if you have something in front of it. But we'll come on to that later. The other interesting thing was that because the crashing and dying application instance was returning a HTTP 503, the proxies and load balancers in front of it were actually going, oh, something went wrong with that instance. I'll best send it on to the next one. And then the next one. So one single payload that was sent in was killing 1, 2, 3 instances, which is quite cool. Now, that has got a number of sort of impacts. So the first question is, will our infrastructure save us in this case? Because, as we all know, we've got lovely infrastructure that is self-healing and auto-scaling and automatically restart things. What's the worst that can happen if you kill an instance of your app server? So the first thing is, of course, you can keep doing it. It's only a single request. Your web application firewall is unlikely to pick that up because it's a single request. It might look a bit odd in the logs, but it's a single request. And this little one-liner, we were talking about one-liners earlier in Tom's presentation, and that one sends 50 requests, one every 10 seconds to that particular payload. So effectively, what I'm doing is playing a game of whack-a-mole. An instance comes up, bash it down, another one. And when that is used in a scenario where you might have, 10 instances that provide a particular service, then very quickly those 10 instances go down. And if that is embedded in 100,000 requests, it might not be easy to pick out, well, which ones are the ones that are causing it. So it's a very interesting sort of vector, this particular thing. So then the question is, well, if the infrastructure hasn't saved us, a WAF certainly will save us. WAF stands for Web Application Firewall. You buy them from Amazon, you buy them from Cloudflare, and they're going to inspect the payload that is being sent through, and depending on some rules, they will deny a particular request. So the good requests and the bad requests, and the WAFs will sort of try and filter out the bad requests. The problem with application firewalls is they still use compute, and typically they will only examine the first 8 or 16 kilobytes of a request. So if you send a payload like this, where you fill the first 8 kilobytes with something innocuous looking, and then fill the rest of it through, the payload will still get through, the WAF will be successfully bypassed, and I still have my denial of service. Now, you could obviously restrict the size of the payloads, but then that gets to be very difficult because different endpoints want different payload sizes. You don't really know what the application is doing. You then have to keep in constant touch with the application developers to ensure that they're not exceeding the payload sizes, and still something might get through. So while we're at the Play framework by default allows a 100 kilobyte payload. So you deploy your application, something like this will be about 60 kilobyte, and it still gets through. It still damages your application. So there's going to be different things that will save us, I'm guessing. So let's talk about the software composition analysis, or just saying, well, we've identified a particular vulnerability. It's been given a CVE. It has been mitigated. There is a new version out for play. Well, there was last year's, and it's been given a score of 7.5. And hands up if you're checking every single CVE in your organization. Who does that? I didn't think so. It's a problem because, especially as CVEs with their scoring, if it's not a remote code execution vulnerability, it doesn't get more than 7.5. So this had 7.5 as the CVSS score, but that's the highest that you'll get. And whenever you're in a vendor presentation about a nice tool that allows you to prevent your build pipelines to letting through bad stuff, they talk about having policies that sets a maximum CVE that it will ban. Well, that will typically get through, because otherwise you end up in a situation where you have got so many things to mitigate that all you'll be doing is mitigating and mitigating. So it's difficult for software composition analysis or vulnerability scanners to just catch everything. Because unless you're at the stage where you only got a very simple service, where you only have got the capacity to update all the dependencies all the time, it's not going to catch it. And normally you don't have that capacity. You will have like hundreds or thousands of microservices that all need to be running through the build pipelines, tested, ensured that it's safe to release. So if you have to deal with lots of CVEs every week, that's not going to happen. Right. So on to my next example of something bad that can happen. Go through the history books. Now this is a CVE from, despite the number, it's from 2013. Again, it has a score of 7.5. It's an interesting vulnerability, because if you look at the XML payloads that I've sort of mentioned on the right hand side there, you've got basically a lot of elements, and all these elements are empty, but they have a name, and that name has got the exact same Java hash code. And you can generate them, and if you have like 100,000 of them, and then in this particular instance, the Xerxes parser tries to parse them, then even though it doesn't crash, it just spends time and time trying to do it. Because what happens is that because Xerxes uses a hash table internally, it uses that to optimize the access to storing the elements, but because all of these elements have got the same hash code, it acts more like a list. And when I tried this out, I was able to keep, a single request was able to keep an application busy for 10, 15, 20 minutes before it timed out. And that then pegs that application at 100% CPU. Now, one time might be okay, but then you do it another time, and then you do it another time. And then the CPU is so busy parsing the XML that the endpoint that you've got for the health check doesn't return in time, so your infrastructure starts killing the thing. And again, if you keep that running, only a handful of requests can have a big impact to the things that you're running. So there's more of those, of course. You can find denial of service payloads in lots and lots and lots of places. And that's not even the code that you write yourself. That is the code that you bring in through libraries. Even harder, I think, is the code that you write yourself, or that your developers write, because as we all know, when software is developed, there are lots of deadlines and pressure, and the product owner wants to have a feature delivered, and can we just refactor this to deal with the technical debt? No, there isn't time. Can we put it on the backlog? To never happen. So a lot of these things might be hiding away. The problem is that a YAML bomb might show up in your dependencies because your configuration is done using YAML, but you're not very unlikely to use YAML as user-controlled input. but are you sure that that's the case? So you're going to have to look. A REDOS, a regular expression denial of service. I think Tom mentioned regular expressions. If you try to solve a problem using regular expressions, have two problems, and that is one of them. If you write it wrong, then you could end up with something that, again, can let your CPU spinning for a good couple of minutes. The old classic from, I think, 2003, the billion laugh attack, where this little snippet of XML creates a gigabyte's worth of memory. Now, a lot of the time, the services that you're running don't have a gigabyte's worth of RAM. So the question here is, are these a problem? If you're in a position where your service is used for authentication, say it deals with SAML, I pity you if it does, but if it is a component of your whole website or your whole offering, where a single service, say the service deals with logging users in, if somebody finds a denial of service vulnerability that they can trigger with a few requests, and if there are lots and lots of requests going to that service that then suddenly no longer work because you've killed somebody's instances, that could be quite traumatic for your service. If you imagine the services that are used for keeping borders and trade open, where calls need to be made, and if that stops, suddenly we've got lorries at Kent. So the problem, obviously, is CVEs. Now, this was where I was working at one client. I was using a tool called X-Ray, which listed all the CVEs and all the artifacts that we had, and it said I had just shy of 1 million worth of occurrences of CVEs. Yeah. Nobody's going to have the ability to look at those individually, and unfortunately, the problem is that a lot of the time, CVEs are only valid in certain contexts. Say, for example, there's a CVE in Log4j, not the famous one, another one where if you use a JMS appender, you can achieve an RCE. Nobody I've never seen a JMS appender used anywhere, but it's still something that comes up in your list of CVEs. So you're going to have a look at all of them, but who's going to have a look at 800,000 different occurrences? Because a CVE depends on the context that it's in. So I actually did that. I took those 800,000 and I ended up creating some aggregation to sort of try and find, well, what are the ones that I'm interested in? And then I started knocking them down. And the actual number of CVEs, the different types of CVEs, was only 800. Once I read through them all and understood how they worked, because I understood how all the services worked, I was able to say, yeah, that's applicable. No, that's not applicable. Yeah, that's applicable. No, that needs a bit more investigation. So it's about sort of creating a pipeline to look at your vulnerabilities. Unfortunately, the tooling that you'll get from the vendor, it's great at bringing you lots of data, but a lot of the time, you still have to put in the work to make use of that data. The fact that you know that you've got 700,000 CVEs is useless. Even if you know that I've got 700,000 with a score of 9.8. Useless, because a lot of the time, as an example, the CVEs with 9.8 are because they use something called polymorphic deserialization, and if you don't use that, you're not vulnerable. So why would you be interested? So you're going to have to work out what your environment looks like, what your services use, So you're going to need some kind of catalog. A catalog can be a full-blown tool. It can be a spreadsheet. But you're going to have to sort of automate some of this aggregation, which sounds awfully like DevOps to me, which is good, because that's where I work. Right, I'm coming to the end now. I don't actually know what time it is, but the lessons for me here are this. It is worth taking denial of service vulnerabilities seriously because they can be exploited. And sometimes when they are exploited, you can do some real damage with it. It is worth examining your content types, because if you don't use XML payloads, then why would you let it through? Because a lot of frameworks automatically accept different types of payloads and then convert between them. It is important to curate your vulnerabilities. To do that, you're going to need somebody to look at them, which I think you're going to have to do some sort of aggregation of the data that you're getting. And of course, it's important to have a lot of defenses and layer them. And I think through that, you can get ahead of these denial of services. Right, and that just leaves me with questions. It's always good when that happens. It either means that I've mumbled, or I've not had a point.